This video introduces batch processing with ArcPy list methods. Specifically, we will review dot notation, for loops, and geoprocessing methods, define batch processing, list data in a workspace, and batch geoprocess. Almost any Python program uses the string and list data types in their methods. To call these methods, you need to use dot notation, object.method. For example, you might write myString.upper if you want to return a value of the string in all uppercase letters. For each question on this slide, write a line of code that uses a string or list method and dot notation. The title of the slide provides the names of the methods you need to use in the same order that you need to use them: split, join, rstrip, index, and starts with. Note that number 2 is probably the trickiest one. Join is a string method, and the object needs to be the string separator, the semicolon, as a string literal. With that, pause the video, please, and write your answers down on a piece of paper. Number 1 says break this comma delimited string into a list, rlist. So it's saying to use a string method, and we have a first string method in our title here is split. So we're going to use the string method on our string record. So for dot notation, how would that look? You should have record dot split, and in the arguments parameters you pass in the thing upon which you want to split. You want to split on a comma, on the comma, to break up this comma delimited string. And note that we specified the name that we want for the list, so that means we're going to use an assignment statement and save it in our list. The output from that would look like this. Notice that you have these blank spaces before these words, and then you have this, remember this is a tab and a carriage return. We'll get to that in a moment, how you get rid of those white spaces. So next, let's look at join our list into a semicolon separated string, semicolon record. This is the one that I said is a little tricky. You need to use the semicolon in a string literal as the object. Remember, it's object.method, and the method that we're talking about here, join. That means it'll be something like semicolon dot join, but you have to have quotation marks around the semicolon. And the argument that you use, you pass in the list that you want to join. We'll use an assignment statement, so we have semicolon record equals, and when we print that out, it looks like this. So it inserted the semicolon between the elements of the list and made it into a string. So split takes a string as it is, and you specify how you want to split it up. And join takes a list, and you specify how you want to join it together. So they're kind of opposite methods. Now the next one says strip the white space from the right side of this record. So we have data record, ID name, latitude, longitude. Actually, this probably is the field names, not the record itself. But if we want to strip the white space from the right side, we want to use that R strip. That stands for right strip. And object.method, the object is record, so record.rstrip, and if we do that on the command line, we'll see that the return value from that looks like this. It's taken off the tab and the carriage return. Number 4, find the index of the first instance of foo in my list. So the index, there's actually a method called index. It's a list method. And so you want to say object.method. The object in this case is the list that you want to operate on. So mylist.index, and then you want to tell it which element, which item in the list am I interested in getting the index, the first index of. And that is passed in as an argument. So mylist.index foo, and what's the answer going to be? If anybody said 3, boo. Instead, you want to say 2 because you remember you're zero-based indexing, 0, 1, 2 position. Notice the first two asked you to use a specific variable to store the results in. The next two didn't, so we're just printing them out. But if you use something like this string method, record.strip, usually you'd want an assignment statement if you're doing anything other than displaying the results, because it doesn't change the value of record. It just returns the modified string. And this one doesn't change the value of my list, even though lists are mutable. It just returns the index into the list of the first occurrence of this. Now for number 5, suppose we have the value of file name set as tree_poly. The question says, check if file name starts with the substring poly. Store your answer in a variable named isPolygon. So we're going to store our answer in a variable named isPolygon by using an assignment statement, and we're going to use the method called startsWith. Our object is file name, so it'll be filename.startsWith, and then what do we want to see if it starts with? Poly. So that'll be the argument, the string literal poly, like this. And of course, our answer to that question is false, because the string literal itself does not start with poly. It has, if we were to use the ends with method, we would get true. Now for another review question. Use loops to print the numbers 2, 4, 6, 8, and 10. First use a while loop, then use a for loop. Remember, with the while loop, you need to have those 3 important components: the initialization of the looping variable, the condition to compare the looping variable, the stopping condition, and updating the looping variable, usually at the end of the loop. For the for loop, remember that we have a built-in function called the range function that you can use to create a list of these numbers and then loop through the numbers. Pause the video now and again write on your paper the answers, your answers to these questions to test yourself. Now remember, while loops have those 3 important parts. So our starting value in this case is 2, our stopping value is 10, and you want to increment or update the looping variable at the end of the loop. So what do you want to increment by? In this case, you want to step up by 2 each time. So your while loop should look something like this one. The only thing that you might have been able to do slightly differently is if you changed your condition. You could say, for example, while x is less than 11, or some other variations. Here we initialize the value of x, we compare, we do a comparison, we check for if it's our stopping point yet, and we're printing the value. If we wanted to print all the values on the same line, we would put a comma here, and that would print them out space separated. And if we do this assignment statement, this sets x equal to x plus 2. So whatever the current value of x is, it gets 2 added to it, and then replaces that x with the current value. So the first time it loops through here, it's going to be 2, and while 2 is less than or equal to 10, yes, that condition is true, so we'll print 2. It'll say x equals 2 plus 2, so x will be set to 4. And then it will go up and check, is 4 less than or equal to 10, and so forth, and keep going around until the condition is no longer met, at which time it will stop. So we won't have an infinite loop. How would you create an infinite loop? Well, simply take out this last statement, and then x would be stuck at 2 forever, printing 2, 2, 2, 2, 2, 2, 2. How would you never go into this loop? Well, you could create a condition that is never satisfied. Say, for example, if you had this sign going the other direction, while x is greater than or equal to 10. It would never go inside of here, because the first time it tries to go in, it would say while 2 is greater than or equal to 10, that condition wouldn't be met, and therefore it would never be incremented to be bigger than 10. These things are dedented inside the loop, so they only get executed if the while loop condition is met. Now, for our for loop, we can use the range method. The range method, again, we have to decide where we want to start, where we want to stop, and what we want to increment by. Since we're doing numerical value, you can simply make this list on the fly inside of here. And remember that with the range method, the left one is inclusive, the right boundary is exclusive. So we had to use something higher than 10 here. We could either use 11 or 12. But this will return the list 2, 4, 6, 8, 10. This range function will create the list 2, 4, 6, 8, 10. And this loop will then iterate through our list that we've created. So it'll point at 2, print 2, point at 4, print 4, point at 6, print 6, and so forth. And that's going through the loop 5 times, comes up and it gets to the end of the list, so it doesn't go in again. Here's a slightly more challenging one, since we haven't yet done a countdown. Write some code to use a while loop and then a for loop to print 100, 75, 50, 25, and 0. For the while loop, keep in mind that you want to start with 100 and go down to 0 by steps of 25. That means the initial value of the looping variable should be higher than the final value. In the case of the for loop, you'll need to do 3 steps because the range function is not designed to count down. First, use the range function to get the list in the opposite order, 0 through 100. Then use a list method that reverses the order of the list. Finally, print the values in a for loop. Okay, so for the while loop, you need to initialize that looping variable to the first value that you want it to have. You want it to start with 100 this time. So we can set that to 100 initially. And we want it to go down to and including 0. So we can set that condition to check if it's still greater than or equal to 0. And finally, we want to make sure that we update the looping variable. In this case, instead of incrementing, we're going to decrement. In other words, go down by 25. So in order to decrement, you use a statement very much like the increment statement, except you can use subtraction. So your solution for this should look something like the one we have here. X equals 100 to start with, and then while x is greater than or equal to 0, print x, and then set x equal to x minus 25. So set x to 100. We check if 100 is greater than or equal to 0. Why, yes, it is. We print it, and then we set x equal to 100 minus 25. That'll be 75. We go around again. Is 75 greater than or equal to 0? Yes. Print 75. 75 minus 25 gives you 50, and that's our new value, and it goes on until we get a value of 0 from this subtraction, at which point it'll say 0 is greater than or equal to 0. It will print 0, and it'll say 0 minus 25. So that'll give us x equal to negative 25. And while x is greater than or equal to 0, will fail because negative 25 is not greater than or equal to 0. So that'll give us our desired results. Now, in the for loop, we can do, well, we said we needed to do some fancy stepping here. So what we can do is create a list from 0 to 100 with these desired intervals, and use that, we'll create that with the range function, and then use the list method that will switch the order. What's the list method that switches the order? It's called reverse. So call the range function, call the list reverse method, and then write a loop. There's more than one way to solve this problem. You may have come up with a different way, but using the description, the instructions here, you would do it like this. So get a list from 0 to 100 with 25 step intervals. So 0, 101, and 25 jump. Reverse the order of the list, and then print the reversed list with the for loop. So this would give us our 100, 75, 50, 25, and 0 desired output. Continuing our review, let's now move on to ArcPy properties and methods. In order to set the geoprocessing workspace to c:\data.mdb, we first need to import ArcPy. Importing ArcPy tells Python to point to the ArcPy module. Okay, so now once we import it, we can do any of those ArcPy methods and call ArcPy properties. So what property can we use to do this? If you said the arcpy.env.workspace command, you are correct. Okay, remember to do this in your scripts. And if you find yourself repeating the path to the workspace in quotes multiple times in your script, then you're doing too much hard coding. You don't want to hard code that path more than once. Just set it in the workspace and then use the fact that you're dealing with a workspace when you're calling ArcPy tools, which pay attention to where's the workspace. So here's another question. How do we get the data type of my file using an ArcPy method? You may recall that there's a describe data objects method, which can be used to get all kinds of information, including the data type of a file. So assuming that my file is in our workspace, we can say arcpy.describe my file. And that will return a describe object. We store that describe object in a variable, DSC, and then to get the data type, we can say dsc.dataType. On the third bullet, we have another question. Suppose we have an input file that we want to clip on the clipping file that's given here, and we want to call our output studyregion.shp, and we want that all to be in our workspace. Oops, maybe the workspace will be something else for this example, because the shape files, you don't want to have those shapefile extensions for being in a MDB. Anyhow, assume you've set your workspace and that these items can be found there. And write the line of code that you would use to call the clip analysis toolbox tool to do this clipping. As a hint, I'll tell you that if you don't remember the parameters for the clip tool, you would be able to look them up in the ArcGIS resources help. So be sure to be able to read the tool signatures and understand those. ArcPy dot and then the name of the tool, and be sure to remember the toolbox alias. And then you pass in the parameters that you need to specify. You need to tell it what input file, and then the file that you want to clip with, and then the name of the output file, how you want to name it. So it looks something like this. So this is another example of object.method. Object.method. DSC.dataType is an object.property. Okay, so we're going to now move on to talking about batch processing, and you'll be using object.method to collect the lists of elements that you're going to batch process. So first of all, what is batch processing? We can repeat individual steps or loop with for and while loops. One of the main reasons to write a script is because you want to do batch processing. Batch processing is the grouping together of sequential steps to be run on a set or batch of items. For example, when your dog has octuplets and you take them to the vet, for each puppy in the batch, the veterinarian will trim his toenails, clean his ears, give him his rabies shot, and so forth. That's puppies, but there's a lot of batch processing in working with data too. You want to rename every file in a directory to include the date when they were modified, or you may want to run land cover analysis on each one of a set of remotely sensed data files, or you want to update the temperature value for each record in a data set. These are just a few examples of batch processing. Batch processing is when you're doing the same step or set of steps on a batch of items. The items could be puppies, directories, files, records, columns, or other things. This is exactly what we're talking about when we discussed repetition in the pseudocode section. And the repetition, pseudocode always uses the for and end for, or while and end while keywords. Remember that when you're writing your project description and what's going to be batch processing. So your project description definitely at a minimum needs to have at least one for loop or one while loop. Otherwise, it doesn't have any batch processing in it at all. So let's look at an example in pseudocode. Suppose you want to rename and reclassify each raster in a workspace, but you want to make a backup before doing so. If you could somehow get a list of all the raster files in the workspace, then you could just repeat the same thing, the same 3 sequential steps for each one of them. Copy, rename, reclassify. Copy, rename, reclassify. Copy, rename, reclassify, and so forth. If you know you only have 2 or 3 rasters, it might be just as fast to do this by hand as to write a script to do it. But if you have 5 or 10 or 100 rasters, if you're going to do this again for several different projects, it really pays off to script it. But in order to be worthwhile, your script shouldn't look like this. It shouldn't look like this pseudocode on the right. That approach will be cumbersome. In fact, it'll become really cumbersome quickly if you need to modify the reclassification parameters, or if you need to run it on 50 rather than 5 files. You can imagine you don't want to do that. Instead, use the batch processing, like the pseudocode on the left. Batch processing pseudocode always uses at least one of the key terms for or while. You can see that this is also going to save a lot of lines of code. So your code is going to be more readable and succinct. Remember how we said if we could somehow get a list of all the raster files in a workspace, we could do this batch processing? If you could somehow get a list of all the raster files in the workspace, then you could just repeat the same sequential steps for each one of them. Well, you might have thought to yourself, what about os.listdir? Good thinking, but unfortunately it doesn't play nicely with the proprietary data types the way we'd like it to. For example, when you look at an ESRI grid raster in our catalog, you see one file. But if you look at it in Windows Explorer, you see multiple files. In fact, you see folders, and then you see a whole bunch of files in the subfolders. os.listdir interprets it just as Windows Explorer sees it, not as our catalog does. Another example of where os.listdir doesn't work as desired is listing data in file geodatabases. It doesn't see a list of feature classes and rasters, just some strange binary files. Can you think of any other examples where it won't work? I'm sure you probably can. Anyway, this lesson focuses on the ArcPy methods that are designed to overcome this. Let's put this all in the context of what we know and what we're going to learn. We know that ArcPy methods and properties allow you to access toolbox tools, set environment properties, get messages from tool runs, as well as other things. We also know that describe objects allow you to get information about the data sets you're dealing with, such as the shape type your feature class has or what the name of the OID field is. Now we're going to look at enumeration methods, which allow you to perform batch processing. They return Python lists of feature class names, raster names, field objects, or other relevant items. Later, we'll discuss cursor objects that allow you to process individual records in the data. We'll also see that other objects can be created. they will have the properties and or methods specified in the pink box, depending on which type of object they are. One example we will encounter shortly is field objects. Quite a bit later in the course, we will also discuss the mapping module and a little bit about how to create your own classes. But for now, we'll focus on those enumeration methods so that we can list data in our workspace. Enumeration methods could be described as belonging to 3 different categories. We'll mostly focus on the first category in this video because we want to just get the basics down, and these are the core ones that you can use to list data sets of different types, of specific types. These methods that start with the word list are called enumeration methods. Enumerate means to make a list of. So the items in the list that it returns are usually strings. Sometimes there's some other kind of object. One thing that's a little bit unintuitive perhaps is that you have to set the workspace before calling an ArcPy list method. You set the workspace and then you just say list feature classes, for example. And that will list all of the feature classes within the workspace that you have specified. If you don't specify a workspace, it may be the default workspace, which is an empty string. And the empty string doesn't contain any feature classes. If you get an empty result, it may mean that you didn't set your workspace correctly. Perhaps you spelled the variable wrong or forgot to put E and V. You'll find that it does not throw an error when you do that. It just silently doesn't set the workspace and makes up a new variable with the misspelling. So we set the workspace. We say arcpy.list feature classes. Arcpy is the object. List feature classes is the method. And we use an assignment statement to store that in fclist. When we print fclist, we get something like this. This is actually a list of file names that are in our workspace. Notice that they are strings. In fact, they are Unicode strings. If you cast your mind back to the lesson on strings, that is simply as a particular encoding of strings, but it really doesn't matter to you. You won't see the little u if you put it in a string format statement to be printed out. So this directory, this workspace contains 2 feature classes, birdfeeders.shape and trails.shape. All of the list enumeration tools have help on the website. So if you go to this link shown here, you get to this web page and type in the help box, or the search box, list datasets, ArcPy, for example. That'll bring up a link to the section that you want to be in. So there's a whole folder called listing data, and then there's a help page for each of the list enumeration methods. These are all the data related ones. So right now we're on the list datasets page, which has, first you want to look at the signature. This is the signature for this method. You say arcpy.list datasets and then parentheses. The 2 parameters listed here are both optional because they have curly braces around them, and then the table says what the parameters are meant to do and the type that you need to use. So you need to use a Python string to specify the wildcard and the feature type, which we will get to in more detail in a moment. Let's look at a simple looping example that uses an ArcPy list enumeration method. Suppose we want to list all the feature classes in ctemp and just print them out. What we would need to do is set the workspace first, and then get the use the list feature classes function, call that with empty parentheses, and then we can loop right through there. for F in FCS because this is a Python list. And that'll go right down the line through each one of the feature class names in the list. Like for example, earlier it would print bird feeders, and then it would print trails.shp for both of those. So let's try and use the list methods for something a little bit more interesting. Suppose we want to delete each and every data set in the ctemp directory. Each and every data set as ArcGIS has defined data sets. So that means that we can use the list datasets method to get our list of things to delete. And then if you don't remember that there's ArcPy, there's a tool for deletion, go ahead and go into ArcPy resources online and search for delete. And it's actually not the top choice, but there is a delete tool. We don't want to delete fields, we don't want to delete features, so on and so forth. We want a generic deletion tool. So we can look at this and syntax, which says that it has one required argument and one optional argument. We just want to specify the required argument. We're not going to restrict ourselves on data type. We're going to delete everything that's in there. So fill in the blanks. There's a blank here. And then once we do that, we can say for D in dsets, fill in the blank. And once we do that, we can say all data sets deleted. I hope that wasn't a mistake. So what are you going to put on these two lines? First line should use this hint. And set it to dsets, because that's what we're using in our loop down here. ArcPy.list datasets. We're not using any arguments because we want to list all the data sets. And then for each D in dsets, we're going to call that ArcPy delete. It was a data management function, and then we'll pass in D, just the one argument. Okay, so it's kind of a simple example. We'll do some more complex examples. A couple things to note about this example. Do you know why we're using double quotation marks here in particular? There's a particular reason. It's because we wanted to use an apostrophe inside of our string. So in order, if we had used a single quotation mark, then Python would interpret that our string started here and stopped here. And then this stuff was going to throw a syntax error because it wouldn't understand what all of this stuff was supposed to be doing here at the end of the line. And what is this character doing? Well, this font is pretty big. My two sentences wouldn't all fit on the same line on the slide. But when I print them out, I want them to all be on the same line. So I used a continuation character so that they'd print out one, so that I wouldn't get a syntax error by not having a quotation mark at the end of this line. All right, so back to batch processing. The examples we have seen so far have used the list enumeration methods with empty parentheses behind them. In other words, we did not specify any arguments when calling these methods. But in fact, most of these methods have two optional parameters, a wildcard and a type. To get familiar with how the wildcard and type parameters can be used to restrict the list that is returned, let's first look at the example of list feature classes, which has optional wildcard and feature type parameters. The wildcard allows us to search for substrings in name. Substrings means just a shorter string inside of the bigger string. And then we can only list files containing those substrings. And we can do it kind of in a flexible way by using this star as a placeholder. And the star, wherever we put the star in the string, will mean put whatever you want in here as a wildcard. That's the wildcard. It can be like if you play cards, you know, sometimes the joker is a wild card. That means it can be used in place of any other card when you want to get that run that's going to make you win the game. So the other parameter, the other optional parameter there is the feature type. And the feature type is so that you can only list files of that feature type. So you can specify that. So let's look at some examples. If we want to list all of the feature classes in our workspace, well, first of all, we have to set our workspace. And how are we going to list all of the feature classes? Simply use empty parentheses. So our list would be like this. Now, in order to list all of the feature classes that contain the string ELEV, we would need to use star as a placeholder so that there could be other things in front of or behind, or nothing in front of or behind ELEV. So it would look like this. Quote, because it's a string, end quote, and we'd put a star on both sides because we want to be able to have anything goes over here and anything goes over here. We're just requiring that the substring ELEV be in there somewhere. If we want to list all the polygon feature classes that start with veg, see if you can think of how that wildcard would be used. So it would look very much like this one, except the string in here is going to be different. And since we want to make sure that it starts with veg, we don't want to have a star at the very beginning. We want it to not have any character other than VEG at the very beginning. But we can let it end with anything, so we can put a star after VEG. And, oops, I shouldn't have showed it so soon. We want to list all the polygon feature classes, then we have to specify that second parameter, the feature type. Okay. Now, what about if we want to list all polygon feature classes, not just those that start with veg, whose names start with veg? Well, we can do that. We just need to put a placeholder in for that first optional parameter. Because if we don't put a placeholder in, we're going to be looking, if we just put polygon here as the first parameter, if we take this out, we're going to be looking for those feature classes named polygon. And there won't be any, probably. So you have to, if you're going to use the second parameter and you don't want to use the first one, you have to put a placeholder in there with that star in quotes, because it's a string. It does mean anything goes. Any name, for any name, pick the polygon ones, polygon feature type ones. The list feature classes has the polygon option, as we saw on the last slide, And in fact, all of the list methods, the enumeration methods in this table have a wildcard capability and a type capability. Type varies depending on the type of data we're talking about. The default for the default value for the type is all. So if you don't specify a type of data set, it will list all of them. You can get a list. You can get these lists from the online help. We were looking a minute ago at the list data sets. Remember, we saw that you could list the coverage or feature or geometric network data types. One thing to note is that for the list tables, this will only list all of these standalone. It'll only return the standalone ones, not the ones. You'll notice that your shapefiles, for example, have a DBF associated with them. If you do ask to list DBase files, it will not list non-standalone files that go along with a shapefile. All of these have only optional arguments with one exception, and that's list fields. We'll get into that a little bit later. Now I'd like you to do another in-class exercise. The instructions are to print each shapefile in ctemp. Assume this directory only contains shapefiles and rasters. Well, okay, we can do that using os.lister, right? And then we can check that if it ends with .shp, and only print it out if it ends with .shp. Okay, so we have a loop here, and then we have an indented conditional block and the indented print statement. But what we want to do now, so what's left for you to try to do, is rewrite this using ArcPy but not os.lister. So if you're going to take out the os.lister, replace it with the list enumeration method, one of the ones that we've been going over for the last few minutes. So pause your video at this point and then we'll discuss the solution for this. Definitely try this one, write it down on a piece of paper and see if you can get it right before looking at the solution. One thing to think about is, will you need a conditional statement anymore? And what additional statement will you need before you use your ArcPy list method? You'll need more than one thing to happen before you do that. So first of all, you'll need to import ArcPy. Now I'm going to go on and give the solution. So if you haven't paused the video to try it, stop now. And then you need to set the workspace environment setting. So this property is set to ctemp, and we call arcpy.list feature classes, and for each feature class in files, printf. For f in files, printf will give us print out of each of the shapefiles in that directory. How do we know that it's not going to get other feature classes other than shapefiles? Well, there are, in our instructions it says that it only contains shapefiles. Now here's another one for you to try with pen and paper. You now know about the optional arguments for list rasters and list feature classes. Both of them have a wildcard optional argument followed by a type optional argument. So go ahead and look at this directory that we have here. This is the workspace. Assuming this is a screenshot from our catalog of the entire workspace, write down the lists that will be returned by this, by each of these commands. Yeah, so list feature classes of point will return an empty list, because list feature classes of point is saying list feature classes with the substring only of, it's not even a substring, with the name equal to point. And though there is a feature class with a name of point, it looks at the extension as well. So the point.shape would be excluded in that way. Usually you never want to use list feature classes in this way. There may be an exception or two, but usually you want to do it because you don't know how many things there are that match your search criteria. The second one asks to list feature classes with the star G star. So that means with G in the name somewhere, right? So if, did I say feature class? I'm sorry, list rasters. So list rasters means you're going to look at all the raster types, and you can tell that by the table that we've got here. It says raster data set or not. And so, and you can also see the little icon. So if we look in this one, it doesn't have a G. This one does. It's at the beginning. That's fine, because we could have nothing followed by G followed by something. The next one does not have a G. The next one does, so that'll be in our list as well. And it has a G in the middle and a G at the end, and that's fine. And the next one doesn't, and the next one does. So we got 3 in our list. Now, the next one is looking for feature classes whose names start with egg and whose type is line. So we do have a line feature class in here, and it has the word egg in it, but it ends with egg. So we probably not going to get anything in that list. We have some there's some other names that have that start with egg, but this one is a polygon feature class, so that one won't qualify either. So that's why we have an empty list. And then we did arcpy.list rasters for any raster name that is a TIFF. So that means list all my TIFF files, and that's what we get. So in this slide set, we discussed batch geoprocessing, or batch processing, and that's grouping sequential steps to perform on a set of items, which could be your puppies, your files, your records, and so forth. The list methods in ArcPy are named to describe what they do. List data sets, list feature classes, list fields. You have to set that workspace environment setting before calling any of these methods, the list feature methods, or the list enumeration methods, and most of them allow you to specify a type or use wildcards. Next, we'll continue to talk about batch processing with some more for loop examples, and we'll talk about why listing fields is different from the other list enumeration examples that we have discussed so far.